So today we'll discuss about the force on a charged particle. Okay, so this is the second segment of the magnetism. So first we discuss about the calculation of the magnetic field. Now today we'll discuss about the force on a charged particle. So if there is a charged particle, so charged particle will feel a force under the presence of magnetic field. So if the magnetic field is there and charged particle is there, so then the force experienced by the charged particle is given by this expression. It is Q into V vector cross V vector. So what is V? V is the velocity which is the particle is moving, and V is the magnetic field that is in there inside which the particle is moving. So this V is nothing but the external magnetic. So this is the external magnetic. And at the presence of external magnetic field, once I place a charged particle, and if the charged particle is moving, so then only it will feel the force. Okay. And since it is a cross product, so what I can say, the direction of the force vector should always be perpendicular to both V and V. Okay. So if I say there is a C vector which is nothing but the A vector cross B vector. So regarding the direction, what I can say that the C vector is a vector which is perpendicular to both A and B. So similarly the situation over here. Here the force is perpendicular to both V and B. Okay. So because of this force, the charge will deviate, but the velocity remains constant. Why? Because the force acting on the charged particle is perpendicular to the direction of the motion. Okay. So the direction of perpendicular to the velocity, and because of that only, there is no change in the magnitude of the velocity. Only thing is that the direction will be changed, that is the deviation will take place. Okay. So in this situation, the charged particle is projected in this direction. Let us say the charged particle Q, and I am projecting this in this direction V, and it is under a dot magnetic field as shown in the diagram. Okay. So if I use the right hand palm rule to stretch the finger towards the V vector, V is the first vector velocity, and stretch the thumb along the V vector and place the finger towards the V vector, then the palm face will be towards upward. So since the palm face is upward, that means the particle will feel a force in the upward direction. Okay. So this is the force felt by the particle whenever the charged particle moves. Now the direction of this force is basically giving the force on a positive charged particle, because whenever I am putting this Q should be put to proper sign. Okay. So either the charge will be positive one or the negative one. So depending on that, the direction of force will be different. So once I do the calculation for the force, every time I calculate the force on the positive charged particle. So if I ask to calculate the force on the negative charged particle, simply reverse the direction. Okay. The only thing is that you have to change the direction. So let us say if I throw the particle in the vertically upward direction, so the velocity V, and there is a cross magnetic field. So if I put the V vector, thumb along the V vector, and finger cross toward into the plane of the paper, so then face of the palm will be towards left hand side. So that is the force. So this is the force on the charged particle if the charged particle is positive. Okay. Now because of this force, now since force is perpendicular to the velocity, rectangle is 90 degrees. So that means this force is not responsible to produce any kind of acceleration. Only thing that can produce is the deviation. So because of the presence of this force, the particle will deviate like this. In this direction, it will deviate. Okay. If the charged particle is negative one, then the force on this negative charged particle will be on the opposite direction. Okay. So that means the particle will deviate in the other direction. So depending on the nature of the charge, the deviation of the particle will be different. Why? Because the force is different. In one particle, the force is acting towards left, and if I change the charge to the negative one, then the charged particle will feel the force towards the right. Okay. So the deviation will be different. Okay. So this is a thumb rule that you should follow to calculate the direction of the cross product. So cross product direction is important. Now let us say, so there is a charged particle. So I project the charged particle in the upward direction, and I want to calculate the what is the direction means the force is being applied on a charge which is positively charged particle. So place your thumb towards the velocity vector that is upward. Stretch your finger towards the magnetic field that is dot out of the plane, and palm face will be towards our right. Okay, so there is the force direction on the positive charged particle. So that is the correct direction of force. Similarly, if I project the same particle, but now the particle is negatively charged, so force will be on the other direction is the direction of force. Okay. So force should be towards our left. So depending on the nature of the charge, the value of the force, magnitude of the force is constant. So here also if I say calculate, if I calculate the magnitude of the force, what is the magnitude? That is equal to dq. Why? Because ideally it should be dq v sine theta. But theta is what? Theta is the angle between the v vector and the v vector. So v and v are perpendicular to each other. So that means theta becomes 90 degree. So it becomes dq. So in both the situations, the magnitude is dq, but the direction is different. Why? Because the charge particle nature is different. Now, what are the factors on which this force is dependent? So first you understand that force depends on the charge. Okay. So charge means if the charge is positive or charge may be negative. So if the charge is positive, if I project the particle, let us say this is a positive charge particle, I project with the velocity v. Okay. I project with the velocity v. So because with v, one positive charge particle, force will be taking upward. So because we force upward force, the particle will deviate in the upward direction, it will deviate in this direction. Okay. Similarly, if I put the charge to the negative one, so for the negative charge particle, if I project the particle with the same speed v, now the force will be downward. Now the force will be downward. And because of the downward force, the particle will deviate in the downward direction. Okay. In both the situations, if I am not going to change the magnitude of the charge, so then the force will be same. Magnitude of the force will remain same. This is always equal to dq v. Okay. So first parameter dependence is the nature of the charge. Second parameter is the if the charge particle is at rest. If the particle is not moving, that is v equals to 0, that means the particle is not moving. So can I say the force is also 0? So force is only feel whenever the charge particle moves. If the charge particle is at rest, so that means v is 0. So if v is 0, then the crossword will be also 0. Okay, that means there is no force acting on the charge particle. Now another thing is that if the v vector is parallel to v vector or it is anti-parallel to v vector, if v is parallel to v vector, then can I say theta equals to 0 degree? Or in the situation of anti-parallel situation, theta becomes 1 degree. So in both the situations, either theta for 0 degree or theta 1 degree, sine of theta becomes 0. Okay, that means force becomes 0. So there are two situations when the force becomes 0. Either the particle is at rest, particle is not moving, or if V and V are parallel or anti-parallel. If in other situation, if F is perpendicular to B and V only. Okay. So that means there are two situations when the force is becoming 0, and in all the other situations, force is not equal to 0. So force is always perpendicular to the direction of the velocity vector. Now, so under this particular force, if I say this is a particular situation where there are different charge particles are there, and let us say I want to calculate what is the direction in which the force is being acting. Okay. So for the first situation, if I say velocity is upward and b is dot, so velocity is upward, b is dot, means force to be toward right hand direction, in this direction the force is acting. Okay. So now this force and v is perpendicular. So every time it should be perpendicular to the velocity. Otherwise, there is one component will come and that will change the velocity. But every time the magnetic force is going to perpendicular to the velocity. Then the second situation, v is toward the angle and b is cross. So stretch your thumb along the velocity vector, finger cross at least into the plane of the paper, and charge is negative. So for the positive charge particle, power will be facing in this direction. But if it is a negative charge, the force will be in this direction. So again you can check this angle is 90 degree. For the third situation, V is dot into the out of the plane and V is somewhat inclined. So now the thumb face will be in this direction. So this is the direction of force on the positive charge particle. Again, the force vector and the velocity vector are perpendicular to each other. In the last one situation, where you can say that now the particle is moving toward cross direction. So V is cross, so place the thumb into the plane of paper and stretch the finger towards B. The thumb face will be in this direction for the positive charge particle, but since the particle is negative, we have to reverse the direction, this is the correct direction. Okay. So every time you have to calculate the force, and that force is called the B2V force, or the mod of the force is B2V. And since this force is always perpendicular to the velocity direction, so this force will result in the particle under the movement of circular motion. And that circular motion is uniform circular motion. Okay, why? Because whenever the particle is projected in a magnetic field, every time the force is in this direction, towards the center of the charge, towards the center of the circle. So that means this force is acting on a centripetal force. What is that force? That is equal to B2V force. And that means it should be balanced by another centrifugal force in this spherical bar. What is R is the radius of the circle. So whenever I throw a particle inside a magnetic field, so that particle try to make a circular path. What is the radius of the circle? Means A should be equal to mv square by R. Okay. So A should be equal to mv square by R. Now what is it? If is equal to nothing B2V. B2V code. So if I simplify this, so R becomes mv by 2. So this is the radius of the circle. So whenever I say that there is a charged particle which is moving in a magnetic field, so then it should always move along a circular track. And what is the radius? That radius is mv by 2. So once I calculate the radius, now I want to calculate what is the time period of rotation. So time period of rotation is nothing but because you have traveled the total distance of 2 pi r. 2 pi is the total distance divided by v. Okay, that is the time period. So if I put the value of r, so 2 pi m v by qv divided by v. So v cancels out, so I will value 2 pi m by q. Okay, so this is the time period. So one of the important findings from the time period expression is that so time period is independent of velocity. Time period is independent of velocity. That means in the same magnetic field, if I project one particle with velocity v, I project the particle with velocity v, and I project another particle with velocity 2v. Another particle with 2v velocity. So 2v velocity particle will perform a larger circle radius. Larger radius. Why? Because r is dependent on velocity. R is dependent on. But for both the particles, the particle which is moving with velocity v or the particle which is moving with velocity 2v, both are having the same amount of time. Why? Because time period is independent of charge, independent of velocity. Time period does not depend on velocity. Okay. Now, apart from time period and velocity, time period and radius, another important parameter that you have to know is the frequency. So, frequency is nothing but 1 upon time period. That should be equal to qb by 2 pi m. 2 pi m. And another parameter is the omega. So, whenever the circular particle is performing circular motion, so you want to calculate the angular velocity, that is omega. That is equal to how much? 2 pi by time period, or can I write 2 pi into 8? Okay, that is equal to qb by m. Okay, that is the omega value. So these are the 4 different parameters. So first is the radius, second is the time period, third is the frequency, and fourth is the omega. So these are the 4 important parameters that you should remember for the particle which is performing a circular motion inside a magnetic. Now that magnetic field is the external magnetic field produced by some other element. So from the earlier class, I know that. So whenever there is a current carrying wire that can produce the magnetic field, so similarly the magnetic field is being produced. And now the charged particle is allowed to move inside the magnetic field, and that charged particle is performing a circular motion. Now these are the radius, time, period, and the frequency. Now this frequency, we will later know that this frequency also known as cyclotron frequency. So that is a separate device that you should learn. So what is that? I will explain it. Okay. So one important fact that you should remember that F is always perpendicular to V. Magnetic force does no work. Why? Because whenever the particle is moving along the circular track, if I say with the force, magnetic force, and direction of displacement is always perpendicular to this displacement. So this angle is 90 degrees. So work done by magnetic force is always 0. Force is always perpendicular to the direction of displacement. So that means work done by the magnetic force is always going to be 0. So that's why we said that magnetic force does no work and energy or speed remain constant. Okay. Why? Because from the work quantity theorem, we know that net work is basically equals to rate change in kinetic energy delta K. Okay. So if delta W equals to 0, that means delta K is also equals to 0. That means A final should be equals to K initial. Okay. So there is no change in the kinetic. So whenever the particle is moving in a magnetic field, inside the magnetic field, so there is no change in the kinetic energy. The kinetic energy always remains constant. Okay. Now there is a charged particle, let us say Q, mass M, is projected with the velocity g naught, which is making an angle 30 degrees with the horizon. Now we are asked to calculate the time spent by the particle inside the magnet. Now whenever I project the particle with somewhat angle, now it will not make a complete circle. It will make a only part of the circle. Why? Because first of all you have to calculate the direction of the force. In this type of problem, first of all you have to calculate the direction of force. So if you calculate the direction of force will be in this direction. Okay. So this is the direction of magnetic force. And along this line, the center of the circle should lie. So this is the O point is the center of the circle that should lie always along the direction of the force. Okay. Now if I complete the circle, so the particle will come out from the magnetic field with the same angle. So it enters at an angle of 30 degrees with the horizontal, so it will give out from this field at an angle of 30 degrees with the horizontal. Okay. With the same speed. V naught is also remain same. There is no change in the velocity. Why? Because the kinetic energy is not going to change. Now, you are asked to calculate how much amount of time will be there which will be inside the magnet. So for that, if I join this point, so this angle has to be calculated. Now this is 30 degrees. So with respect to vertical, this angle is 60 degrees. That means this is 30 degrees. So this is 60. This angle is half angle is 50 degrees. This half angle is also 50 degrees. This total is 120. So up to a time of 120 degree, up to angle 120 degree. Why? Because the particle will be inside the magnetic field for this much portion. This is the portion where the particle will perform the circular motion. So it is the arc of a circle. So how much degree? 120 degree. So I know that for 360 degree rotation, it will take T amount of time. For 120 degree rotation, it will take T by T amount of time. So that will be your answer. So it will be remain inside the magnetic field for a time of T by T. Okay. So you have to calculate the value of T. So what was T? So T is 2 pi m by 2. 2 pi m by 2. What is known? Because all the parameters are given. You can calculate the capital T number. Once you calculate the capital T, so you can say how much amount of time will be there inside the magnetic field, that is T by 2. Okay. So this is how you should calculate this type of problem. Now, let us say, now consider one situation where there is a particular situation, there is a region, let us say this is the region inside which the magnetic field is of width d. So d is the width of the magnetic field. Now we project the particle with a velocity v such that the particle is performing the circular motion, but the radius of the circle is less than the t number, more than the t number. Okay. So then it will come out from this point. Why? Because it cannot complete the whole circle. It cannot complete the whole circle. So at this point, if I draw the force, so force will be in this direction. Okay. So if I take this is the center of the circle, so correspondingly, particular point A will leave from this magnetic field at point B. Okay. So at point B, it will come out from the magnetic field. Why? Because the R number is now more than the D value. Okay. R number is more than the D value. So now you are asked to calculate the deflection, the angle of deflection. The angle of deflection is theta. So let us say the particle is coming out with the same speed at point B, which is making an angle theta with the horizontal. So you are asked to calculate the value of theta. So for that, what you should do? You should draw a line from B like this. If I say this angle is theta, so that means this angle is 90 minus theta. That means this is theta. That means that is also theta. Okay. So for this half triangle, for this OBC triangle, So for the OBC triangle, can I say sin theta number should be equals to D divided by R? Okay. So that will be the expression for the theta. Okay. So sin theta equals to D by R. So this expression only valid whenever the D value is less than 10. Okay. What is D? D is the width of the magnetic. So there is a certain region inside which created a magnetic field whose width is D, whose width is small d, and if the particle related to such such that the capital R number is less than D, then only the particle will come out. Okay, then only the particle will come out. If I say, let us say D is equal to R by D, but yeah. So D less than R is always true. Why? Because sin theta has to be less than 1. Sin theta has to be less than. Cannot say D greater than. If the particle such that it will, let us say, if the situation D is equals to R by, so D equals to R by 2 means theta should be equal to 30 degree. So particle will come out at an angle 30 degree with respect to horizontal. That 30 degree angle equals the deflection angle. Now consider another situation where the D distance, this is the D region, which is greater than R. If D is greater than R, we throw the particle, so particle has tendency to complete the entire circle. Okay. Why? Because now this R length is less than D. Okay, R length is less than D. So now the particle can complete the entire circle. So in that situation, if D is greater than R, then the angle of deviation then the angle of deviation theta should be taken. Because why? Because I throw the particle in this direction. I throw the particle in this direction. And the particle is coming out in the opposite direction. So what is the angle? So that angle of deviation is 180 degree. Okay. So whenever the region is more than the radius, then the particle will complete the circle. That is the region less than the radius of the circle. It will go enough space to complete the circle. Right. So then the part of the circle will be completed. So this is the part of the circle. This is the part of the circle. So particle will complete a part of the circle. And because it is part of the circle, the particle is coming out at a certain angle, not the one. So this is given the value of theta. So theta is the angle of deviation of the particle as it comes out of the magnet. Okay, it will come out. Now, so the application of this instrument, one of the applications is mass spectrometer. What is spectrometer? Spectrometer is a device used to separate the two parts. Okay. Let us say we have a source, ion source. Inside the ion source, we have a mixture of C12 and C4. Okay. So carbon 12 and carbon 14 are there, and those are in a mixture. Okay. So now you want to separate. So in order to separate that, you have to go for an instrument known as spectrometer. So inside the spectrometer, what is happening? So these are basically charged particles. First of all, ionize. Once I ionize, now I project charged particle. Okay, velocity, let us say v. I project it into velocity in the place of the magnetic. So if I project this inside the magnetic field, then I know the charged particle will do the circular track. So I calculate the radius for the R for the let us say CPL. So that should be equal to mv by qv. Okay. Similarly, R for C14 should be equal to mv by qv. But I know that K means 4 for 14. C14 is not heavier compared to CPL. So C14 radius will be more. So once I calculate this, I know what is the radius value. Depending on that radius number, if I make a hole over here, so from this hole the C14 will come out. From this hole the C14 will come out. Similarly, if I made another hole for the C12, so from this hole the C12 will come out. Both are not coming out from the same hole. Why? From the radius of targets will be different for the two different particles, because these two particles are different. Massive wise they are different. Since the masses are different, they will come at different location. And now I can separate the C12 and C12. So this is known as the spectrum. Spectrometer uses the basic principle of deflection of the charged particle under the presence of magnet. Once I put switch on the magnetic field and we allow the charged particle to move inside this magnetic field, so then the charged particle will take. And depending on the radius, if I mark the two different outlets for C12 and C14, so it will be coming out. Okay, so this is one of the instruments. Another instrument is called electron gun. Another instrument called electron gun. What is electron gun? Electron gun is a particular device which is used to produce the high-speed electron. Which is used to produce the high-speed electron. So initially, what is there? So I took a coil. So this is the coil part. There is a coil, and I allow a very high potential difference across this part. Let us say D prime. So D prime means the potential difference created across this coil, and this D prime should be in the kilovolt range. In the kilovolt region. So that means I am supplying a large amount of current to this one. Because the large amount of current, the coil will be heated up, and because it's heating, some amount of electron will be released. Some amount of electron will come out. The removal of electron at high temperature is called thermoionic emission. So these electrons are emitted because of the thermoionic emission. Okay. So now the electron that has been ejected from this metal coil would have very low waves. Okay. So once you get this electron, now your intention is to increase the speed of the wave. So for that, what you do, you are applying you are doing this entire experiment in a setup in a glass. So it is a glass tube, closed. Glass tube. So inside the glass tube, we are making two different gates. One is a positive. So because of that, the electric field creates an illumination. Electron will always move opposite to the electric field. So electron will be gradually moving because of the electric field and ultimately gain some kind of energy. Okay. Now you want to calculate what is the velocity with which the electron is coming back. So for that, if we apply the energy equation between initial final point, if I write Ki plus Qy is equal to K plus Ux. Ki is the initial kinetic energy. Initial kinetic energy is 0 as electrons are emitted from the metal coil. 0 is. Now what is potential energy? Potential energy is the electron potential energy, nothing but the potential into charge. So potential is 0. Why? Because there initially has a 0 volt potential. Okay. So it is also 0. Final kinetic energy, let us say there is half of this and potential energy. So electrons are coming toward the positive side of the battery. So potential is capital V and charge is minus. So I can solve this should be equals to V should be equals to EV 2EV by M. Velocity of the electron is also under the 2EV by M. So this is the velocity that you can obtain from the electron part. Okay. Now if I make one estimate, let us say I put a potential difference of 1 volt. Let us say I put a potential difference of 1 volt across the electron gun terminal. So corresponding to that, what is the velocity that I am getting? Electronic charge is 10 to the minus 19. Okay. And divided by mass, 10 to the minus 31. Root of that. That means it becomes 31 minus 9. Yeah, 31 minus 19 means 12. 10 to the power 6. So roughly 10 to the power 6 meter per second velocity that you are getting for this. That velocity is not so much high. Okay, that velocity is not so much high. So I want to increase the velocity part. I want to increase the velocity part. So electron gun is basically a device, as I have already said, that it is used to produce a high speed electron. High speed electron. So comparatively very high speed electrons are being obtained. So now further increase in velocity can be done if I increase in V. If I increase this V. So increasing V value will certainly increase the velocity of the electron, but that potential difference increment will basically involve some amount of cost. Why? Because more amount of battery has to be applied. So the larger size battery, that is the cost involvement is there. So that is not so much feasible. If I cannot increase the velocity further. So if I repeat the same experiment for the alpha particle, let us say if I repeat the same experiment for the alpha particle, if I substitute the value, so I am getting this function for the alpha particle equals to total charge. What is the charge of alpha particle? That is 2 and V. Here is mass. Mass of alpha particle is 4 times the mass of proton. Okay. So ultimately what I am getting is V by A. Good. Again, let us say I am applying the same potential difference of 1 volt. So in the numerator it is 10 to the power minus 90 and the denominator 10 to the minus 27. Good. Okay. So potential of 90 is 8. Yeah. 8. 27 minus 19 means 8. So then you can do a 4 meter per second. So the velocity of alpha particle is still less. For the electron I am getting in order of 10 to the 6 meter per second. But for alpha particle I am getting the velocity in a range of 10 to the 4 meter per second, which is on the lower side. Okay. So now the objective of this is that I want to further increase the velocity. So you can increase this by increasing the V. If I increase the potential difference between one dimension, then certainly the velocity will increase. But that increasing velocity is not so much. It is small increase in velocity is possible. So in order to increase it further, you should go for a device which is known as cyclotron. The cyclotron is the device basically which is used to produce high-speed electron, high-speed charge. High-speed charge. Why it is essential? Because in order to do some kind of experiment in nuclear physics, we need charge particle which should move with a very high speed. Very high speed. So in order to get those high-speed charge particles, so I should go for an instrument which is known as cyclotron. Now how the cyclotron looks? So this is the cyclotron. Okay. The cyclotron is made up of 2 Ds. Okay, these are called Ds. Okay. So D type cross section and allow the charge particle to move inside the D by applying 2 different fields. One is the electric field and another is the magnetic. Okay. In electron gun only I am using the electric field. But here I am using the concept of magnetic field. Okay. How? So for that I am using an AC source. This is the AC source of electric field. So there is a AC source of electric field is applied across the D. So what is AC? AC is that every time the polarity is changed. Okay. Polarity is changed. If I say this point is the total time. Capital T. So this is the capital T by 2 is the T. Okay. So for half of the time period, from 0 to capital T by 2, half the time period, let us say this left side D is positive charge, positive plate, and left right side D become negative. Okay. And from T by 2 to T, the polarity will reverse. This is right. So the polarity of the D are every time reversed. That is one side, one D is positive, another D is negative. For the next time interval, the D that was positive is negative. That means the polarity is going to be changed every time interval T by 2. From 0 to T by 2, polarity remains fixed, and then again T by 2 to T, the polarity is going to be changed. Okay. Now, regarding the magnetic field is cross magnetic. Magnetic field I am putting a cross magnetic field across that. A very strong magnetic field is created in the cross direction so that the magnetic field is directed into the plane of the vessel like this. So this is the direction of magnetic field. Now if I allow the charge particle to go inside this, let us say initially the charge particle that has been created from the electron gun is allowed to go at this point. Let us say over here. So once the charge particle is released from here, now I am saying that initially the positive end is over here and the negative plate is. So because of the electric field, now the charge particle will push towards this direction. Okay. Initially, one of the negative side of that's one side. Are you listening? Yes, ma'am. So initially, let us say the left hand side of the D is positive and right hand side D is the negative. So that means the electric field is in this direction. Because the electric field, the charge particle move from point 1D to the other. Once it goes inside the second D, now because the magnetic field will try to move in this direction. Okay. So along a circular track it will move. Now once it comes to at this position, now the electric field has to be reversed. Okay. So starting from this point to that point, so up to this blue line, the particle is traveling, maintaining the situation that the left hand is positive and right hand is negative. Now once the particle comes over here, now the polarity will change. So now the left hand will become positive, right hand will become negative. Okay. So now because the electric field is changed also direction. So now the particle will go in this direction because the electric field. Now again it comes inside the magnetic field. So the perform a circular motion like this. Okay. So once again the particle comes over here, the charge electric field has to leave. So like this way, every time the particle inside the P and the electric field has to revert so that it will continuously rotate in the circular. So because of electric field only, the particle will accelerate. For electric field only, the particle will accelerate, and every time the velocity of the particle is going to be increased. Now, since the velocity of particle is going to be increased, so that means the radius of the circle, that is mv by q, that is also going to be increased. Why v is increasing? Okay. So because this, the radius of the circular loop is also going to be increased, and ultimately the particle will come out from this entirety from the extreme end like this. Okay. But the radius is the largest. So this is the idea of the cyclotron where several times the particle has to be go to this thing. So once the this point to this point, now the electric field is acting in this direction. So particle move in this direction. Now once the particle comes over here, the electric field has to reverse it. The particle goes from here. Now it again move along a larger circle. Then goes to the electric field. Like this way, every time the electric field is converting directing the particle towards the D to form the larger circle. So the separation between the each and every circle. So this is known the pitch. This is known the pitch. There is nothing but the change in diameter, not the change in radius of the circle. As the velocity is going to increase, so multiple times if I rotate it, if I rotate it inside the wheel multiple times, that means the velocity is further increased. So by this method, I can get a very high speed charge part. Now, so this is the first type of cyclotron that has been used by the scientists Lawrence and Livingstone in the year 1934. Okay, so it is used to accelerate the charge part or ions to higher energy. Why? Because there is certain experiment which requires this. Okay, so there are two semicircular discs known as the Ds are used. These are the metal content. So we produce a cross magnetic field inside this disc so that the charged particle will perform circular movement. So magnetic field makes it go around the circular path inside electric field, sign of the electric field has to be changed alternately so that the particle will always accelerate. So this acceleration created by the electric field of the charged particle ensures that the particle will get high amount of energy. That is the basic difference. Okay, you want to get a high amount of energy for this charge. So for that you are using the cyclotron device. Okay. So corresponding to the cyclotron, so I know that the frequency of oscillation in a charged particle for a charged particle in a magnetic field is this power. So the same frequency has been taken change the electric field intensity. Why? Because electric field, I have said that electric field is not sine of omega. What is omega? So this omega number to be balanced with that one. Okay. So then only whenever the particle is coming to 1D, at that instant of time the reverse polarity should take place so that the particle cross that. Hmm. So it can be only ensure that the time period or you can say frequency is independent of velocity. In the earlier segment, I understand that the time period of frequency is not dependent on velocity. If it is dependent, then it will be quite difficult to operate the circuit. So the circular frequency, angular frequency of the source must balance with the frequency of oscillation of the charge particle. So radius is basically radius is equals to mv by q. Yeah. So same, they have the same energy. All three particles have the same energy. So numerator is basically momentum. mv is momentum. So it can witness under the 2 m kinetic energy. Then by qv. Yeah. That will be proportional to what? Proportional to root of m by q. Got it? So these are radius in proportion to root m by r for rotor by d. R for electron root of me by e. R for helium alpha particle should be equals to 4 mp by root of 4 mp by 2e. That means mp root by e. R for proton and alpha particle both are equal. Now regarding the radius of electron, so less. Nah, root of AB by so RE is less than RP equals to B option. So where there is a charge particle Q mass equals to minus V for a large place in YZ plane. Thus these are Z axis, these are Y axis, and these are X axis. Okay. So screen is placed in YZ plane. That means this is our screen. Let us say. This is the screen that has been placed in the YZ plane. Okay. A particle moving towards the negative x-axis. Let us say the particle moving towards this direction. In this direction. Okay. So magnetic field is towards K. That means upward. So magnetic field is upward. Upward. So minimum value for V for which the particle will not hit the screen. So distance of the at a D. So is a distance towards the left. So this is the distance D. So distance of the field, distance of the screen from the particle is D. Okay. That is distance of D, the field, the screen is there. Okay. So because of this V, the particle deviate. Particle deviate in this direction. V cross B means force will be in this direction. In this direction. Okay. So that means the center of the circle will be over there. Center of the circle will be somewhat over here. So particle will deviate like this. So there is a circle that the particle will try to make. Okay. This is the circle. Got it? So this should be the R value of the circle. What is R? R is D. So R should be equal to D, that should be equal to mv by qv. Okay. We are asked to calculate the velocity v. So v should be equal to how much? V should be equal to qvb by m. qv, correct. Yes. Okay. Lorentz force or velocity select. Setup. So again, the concept is under the magnetic force. Now our magnetic force under আমরা করব কি এটাকে চেঞ্জ করব। সো আমরা আগের সেগমেন্টে দেখেছিলাম যে ভি ভেক্টর ইজ পারপেন্ডিকুলার টু দ্য ভি ভেক্টর। হ্যাঁ, now we study the motion of a charged particle in the magnetic field where v is at an angle theta with v. V is not perpendicular to v vector, it is at an angle with v vector. So at an angle যখন থাকবে, let us say it is making angle theta with the v vector. So v is along the yellow color vector direction, v is along the blue color direction. So corresponding to this, can I say that v cos theta numberটা v cos theta is parallel to the v vector and v sin theta is the component which is perpendicular to v vector. So v sin theta is perpendicular to v and v cos theta component is parallel to v. Okay. So whenever there is a charged particle is thrown inside a magnetic field with velocity v, I know that it will perform circular movement, provided this radius, এই যে রেডিয়াসটাকে বের করেছিলাম আমরা, রেডিয়াস ইজ ইকুয়ালস টু mv বাই qv বলা হয়েছিল, and what is v? This v is basically the velocity which is perpendicular to the v vector. So this is nothing but the m into v perpendicular component divided by qv. Why? Because now the v is perpendicular to v magnetic field. Now only thing is that whenever the v is somewhat inclined, whenever v is somewhat inclined with velocity somewhat inclined with respect to v vector, so then there are two components of the velocity. One is parallel to the v vector and is perpendicular to the v vector. So perpendicular component of the velocity is responsible to produce the circular movement, and parallel component will produce the movement of the particle along this direction. Okay. So there are two motions. So that's why it's called the helical motion. One is circular motion, another is the forward movement. So this is the circular movement. The circular movement is due to the perpendicular component, and there is a forward movement also. Why the particle forward movement? Because this forward movement takes place because of v parallel component. And the circle radius, the circle is being formed, and whose radius, this is the radius, the r is dependent on the perpendicular component. So what is r? R should be equal to a into v perpendicular by q. Same formula I am using. Only thing is that instead of writing v, you should write v perpendicular. What is that component? That is m v sin theta by q. Okay. So that is the new radius. That is the new radius. And because this circular movement, the particle performs circular track. And in each and every circle movement, the circle is always forward advanced. Why it will be advanced? Because of this parallel component. So distance between two successive points of the circle is basically known as the pitch. In order to complete one circle, I know that the particle is requiring a time of capital T. What is capital T? So there is no change in the capital T parameter. There is 2 pi m by qv. Inside the capital T parameter, there is no effect of velocity. So in capital T time, how much is the forward advancement? So initially, let us say the first circle. Now the second circle. Now what is the separation between the first circle and second circle? That is called the pitch. That is called pitch. Now what is that pitch? That pitch should be equal to v parallel component multiplied by t. V parallel component multiplied by t. So every time the circle is going to advance by this equal distance v parallel into t. Okay. So entire path is known as the helix path. Helix is formation হচ্ছে একটা. Because the helix formation, the path is forward movement. Okay. So all the circles are of equal radius. All the circles are of equal radius. R is same, but in each rotation, the circle is advanced forward by a distance of h. Okay. So what is pitch? That is 2 pi m by qv into v parallel. And R is what? M into v perpendicular by qv. Okay. So every time there are two components of velocity. One is parallel, another is the perpendicular. So what is P? P is the distance traveled along the magnetic field line in one complete cycle. একটা complete cycle কতটা এগিয়ে যাচ্ছে। The distance that is in forwardly advanced. Now, the difference between the electric force and magnetic. So magnetic force is always perpendicular to the field line. Whatever the direction of magnetic field, perpendicular to that, the field line exists. Electric force is collinear. Electric force is collinear. If I say the electric field line is in this direction, so tangent to this is always give the force direction. But for magnetic situation, if I say this is the magnetic field line, so force is always perpendicular to this. Force is always perpendicular. So this is the first difference between the electric force and magnetic force. Magnetic force is velocity dependent. Magnetic force is velocity dependent. Why? Because the force is offered on the charge particle. Force is offered on the charge particle. আমরা লিখে দেবো Q into V vector cross V vector. So as I increase the V value, the force is going to increase. It acts only when the charge particle is in moving condition. While electric force is independent of state of the rest or motion. If the particle is at rest, then also the force is acting. If the particle is moving, then also the force is acting. That force is Q into E. Now electric field accelerates. Electric field always accelerates the charge particle, while magnetic field always deflects the charge particle. So in the presence of both, whenever the particle is experiencing both electric force as well as the magnetic force, then due to the magnetic force, the deflection will be there, and due to the electric force, the particle will accelerate. So magnetic force does no what? That is another important point, because force is always perpendicular to the displacement direction. Okay. Now combining these two forces. So on a particle, if I say there are two different forces are acting, one is the electric force and the magnetic force. So vector sum of these forces is known as the Lorentz force. So F is basically Q into E vector, Q into E vector, and FB is basically Q into V cross B. So on a particle, if I say both the forces are present, then instead of saying that force is either electrostatic or magnetic, I should say the force is Lorentz. So Lorentz force is a particular type of force which is acting on the particle whenever there is a both electric field as well as the magnetic. Under the presence of both electric field and magnetic field, the particle will experience a Lorentz force. Now, if I repeat the same experiment that we have already explained during the wasted experiment. So if there is a current coming where and there is a charged particle, if the charged particle is projected, so then it has been observed that the charged particle will deviate. Charged particle will deviate. So that deviation is due to the magnetic force. So there is a deviation. That deviation is due to the magnetic. So now if I observe the same behavior of the charged particle by placing myself in a leaf, which is also moving with the same velocity, then so this deviation is seen by the observer on the ground. Okay. So the observer who is on the ground, he sees the deviation. But so there is no deviation for this particle. For this observer who is standing inside the leaf. For the man inside the leaf, magnetic force becomes zero. Why? Because with respect to man, the particle is at rest. With respect to man, the particle is at rest. So since there is no magnetic force acting on the particle with respect to the man which is in the leaf, so for that, so still the deviation is there. Now electric force is responsible to produce that deviation. So then how the particle deviates? So this is because on this frame now the electric field will come which creates the deviation. That means what we understand that in this situation, whenever I observe the particle with respect to ground frame, then magnetic force is responsible to create the deviation. And once I observe same particle with the leaf frame, the electric force is creating the same deviation. So that means both magnetic force and electric force are frame dependent. On a particular frame, the effect of magnetic force can be observed. On other frame, the effect of magnetic force cannot be observed. That means these two forces are frame dependent. These two forces are frame dependent. So in order to make the problem simplify, we introduce the concept of Lorentz force, So Lorentz force is frame invariant. In which frame I am observing the particle, it is symmetry. So Lorentz force is independent of frame. On any of the frame, I can see the force. So electrostatic force and magnetic force both are frame dependent. But Lorentz force does not depend on frame. Lorentz force does not depend on frame. So with respect to lift, I should say the force acting on this particle is the Lorentz. Lorentz force, because now I cannot see the magnetic force. The person who is inside the lift, for that person, the particle is not experiencing any kind of magnetic force. Why? With respect to him, the particle is at rest, because both are moving the same speed, same direction. Okay. So with respect to lift, the particle is not experiencing any kind of magnetic force. Instead of that, on that frame, now the electric force will come. That means what is there? That the Lorentz force is coming. Okay. So with the help of this Lorentz force, now we go inside a particular thing, instrument is known as the velocity selector. What is the purpose of velocity selector? Now in velocity selector, there are condition is that there are multiple number of charge particles. Let us say there are multiple number of charge particles in that. Now we want to make the charge particle to pass without any deviation. That means along a straight path. So I want to make sure that these charge particles should pass along a straight line and it will pass through a hole. Okay. So that means I want to make sure that some of the charge particle which has a particular value of velocity, those charge particles will only pass through that particular. So for that I am making a setup where both electric field and magnetic field are being established. Okay. So there is a north pole and south pole. So that means in this situation, magnetic field is in this direction, V is actually there. So because in magnetic field, the positive charge particle will feel a force in the upward direction. This is the BQV force. Okay. So if I say only the magnetic field is there, and because of that, the magnetic force will come into the picture, and the particle will deviate like this upward. Okay. Now, along this direction, along this downward directions, I am applying an electric field. Here I am putting electric field. So because the electric field, now the particle, positive charge particle, will feel a force in the downward direction. So that is AP. So if these two forces will balance each other, BQV and QV, these two forces will balance each other, then the particle will be undeviated. It will move along a straight line. And if I balance these two, that means BQV, that should be equals to Q into E. So Q and Q cancels out. So V should be equals to E by V. So the particles which has a particular value of velocity, which is the ratio of E by V, will only pass undeviated. Okay. So only the particle with this particular speed pass undeflected through this reach. So Thomson used this experiment or method to find the electron charged by mass ratio. Charged by mass ratio of electron for the electron. Okay. So this is called the velocity selector. So in velocity selector setup, the charge particle should move undeviated. Undeviated means the velocity should be balanced in such a way so that there is no deviation. So particles are moving in a straight path. Okay. Now consider the situation. So let us say first case I say that E and B and V both are parallel to each other. Both are parallel to each other and all are uniform. So let us say B is along x direction, E is along x direction. Now you release the particle. So once I release the particle, so since it has no velocity, let us say if I put a certain velocity, let us say V, if I put V. So now V becomes parallel to B. Now this charged particle will not perform circular motion. Why? Because V is parallel to B. So there is no effect of B. There is no effect of B. With the effect of electric field, the particle will accelerate in the forward direction. Why? Because the acceleration will be how much? That should be equal to force, that is E into Q, here a mass. So with this acceleration, the particle will move in the forward direction and the path will be a straight line path. Okay. So particle will move along a straight path in the forward direction. When both E vector, B vector and V vector are parallel to each other. Now consider a situation where now the V is perpendicular to B. Now once the V is perpendicular to B, Now it will follow a circular. Now it will follow a circular path. So because of this V and B, the particle will follow a circular path. Let us say this is a circular track whose radius is mv by qb. And because of electric field, the particle will also accelerate in this direction. Okay, that means it is a kind of helical motion, but with variable. In the first case, what we say that if the V is inclined, there's two components, one is parallel and one is perpendicular. But now I am saying that V is perpendicular to the velocity vector is perpendicular to the magnetic field, and because of that, the radius of the circle will be how much? Radius of the circle will be mv by q. But the particle is accelerated forward. Accelerated forward. For each and every circle, the time period remains same. Okay. Let us say this is the first circle. Let us say this is the second circle. So the distance between the first circle and second circle is pitch. So what is that pitch? That should be equals to half at square. What is A? A is basically acceleration equals to Q into E by M into T square. Okay. What is capital T? T is equals to 2 pi M by Q. Okay. That is the pitch one. Now if I want to calculate the second pitch, let us say the third circle. So third circle means this difference is a P2. So what is P2? Can I say P2 should be equal to half A into T whole square minus half A into T square. Okay. So 2T is what? Up to 2T times the particle is performing third circle. Up to T time particle is performing second circle. So difference between these two distances is nothing but the P2. If I simplify this, it should be equal to 4T square minus T square means 3T square. So half A into 3T square. Okay. So initially it is equals to half AT square. First pitch. Second pitch half A into 3T square. Similarly, third pitch. Third pitch should be P3 can be written as half A into 3T whole square minus half A into 2T whole square. That is 5. So half A into 5T square. Okay. So gradually the pitch is increasing. So it is a variable kind of pitch. Variable kind of pitch. So ratio of P1 is to P2 is to P3 is how much? 1 is to 3 is to 5. Ratio of P1 is to P2 is to P3 is equals to 1 is to 3 is to 5. Okay. So in this situation, the particle will perform a helical circle, but the pitch is variable. Okay. So now if I make it somewhat angle, then only thing is that the component which is perpendicular to the magnetic field, that you have to take care about the formation of the radius. So the V perpendicular. Okay. So V perpendicular is how much? V perpendicular V naught sin theta. Okay. So radius of the circle, helical pitch circle, so that should be equal to M V perpendicular by Q. Okay. And there is one component of velocity along the forward direction, V naught cos theta. Okay. So that is the initial speed. And acceleration is how much? Acceleration is again QE by M. So now the pitch will be different. For the first pitch, if I want to calculate the second, the pitch circle line will like this. Okay? So every time the pitch is going to increase, so pitch one is how much? That should be equal to ut plus half at square. What is capital T? Capital T, there is no change, that is 2 pi M by Q. Same capital T is there. Now the U will come. What is this U number? That is V naught cos theta. Half at square. What about P2? P2 should be equals to U2T plus half A into 2T whole square minus UT minus half at square. Okay. So like this, you can calculate the P1, P2, P3. Again, the pitch will be variable. Okay. So if the angle is somewhat inclined, then the particle will do the helical path, again with variable pitch. But if the angle is obtuse angle, so here I am considering the acute angle. If the angle is obtuse angle, then the pitch will be in the backward. So there is a some part will be backward helix. So particle will initially try to do a helical movement in the backward direction. So ultimately one point will come when the velocity becomes zero. Why? Because acceleration in this direction. Acceleration in forward direction. Initial speed in the negative direction. So ultimately the speed will decrease. So particle will come to a rest. Then from this point onward, again the forward helix. From this point onward, again the forward helix will come. But in the entire situation, again the helical path will be there and variable peak will be there. Okay. So these are the different variety where I should consider the particle will form a helical path under the presence of both electric field as well as the magnetic. R should be equal to mv perpendicular by qv. M is 1.67 into 10 to the power minus 27. V perpendicular is V sin 53. So 5 into 10 to the power 5 sin 53 means 4 by 5. Charge of the proton. Proton is E. That is 1.6 into the minus 19. And magnetic field is 1 Tesla. How much? 4.2 centimeter. Again, pitch of the helical path. Pitch of the helical path is equal to taken by the proton. So pitch should be equal to how much? Half AT square. এখানে A থাকবে না. Only thing is that P can leave account for V parallel into capital T. There is no acceleration. So V parallel is how much? V cos of 53 into 2 pi m by qv. So V is 5 into 10 to the power 5 cos 15 in 3 by 5 into 2 pi m 1.6 into the minus 27 by q means 1.6 into the minus 19 into b is 1. কত 5 কাটছে এটা কাটছে এগুলো সব কাটছে 2 pi হচ্ছে 2 pi into 3 6 pi 6 pi means 19.7 19.7. Okay. Being a proton with the speed of this much enters uniform magnetic field of atom at an angle 60 with the magnetic field, the pitch of the resulting path to be close to. Very good. Please very first. P remove V parallel into T. V parallel means cos 60. So 4 into 10 to the 5 cos 60 means half into 2 pi m 1.69 into 1.67 into 10 to the power minus 27 by qv 1.6 into 10 to the minus 19 into 0.3. দেখো 2 হলো এখানে সব কাটাকাটি হয়ে গেল 2 by 0.3 4 pi by 0.3 pi আর 0.3 গেলে হ্যাঁ 5 সেন্টিমিটার রাইট 5 সেন্টিমিটার. Now positive charge particle Q moves along the z axis. There is a positive charge particle, it is moving along the z axis. This is a positive charge particle. While electric field are as shown in the figure, electric field, magnetic field both are parallel to each other. If E and B are uniform, what kind of motion will this particle will keep? Now V is perpendicular to B. So V is perpendicular to B means there is a circular motion. So there is a circular motion and the radius of the circle. So V is perpendicular to B. V cross B means thus force will be in this direction. So particle will perform a circular motion like this. So this is the circle, okay, radius, and it will be forward advanced. Why? Because it will be advanced forward by means of electric field. Okay. So whenever the electric field is there, it will try to pull the circle forward. And since the electric field is there, so forward movement will be accelerated. That means it is a kind of helical path. Okay, with a variable pitch. Helical path with a variable pitch. Now, uniform electric and magnetic field with strength E and B are given are along y-axis. A particle QM leaves the origin O in the direction of x-axis. The initial between V naught, time period of its helical movement. So, because of this V naught, so it will experience a force in the z direction. Because the V naught in the x direction, the particle experiences a force in the z direction. So this is the force, magnetic force. So particle will experience a force in the direction. So particle will perform a circular motion like this. So this is the circle, and circle will be move upward with the help of electric field. With the help of electric field. So helical movement time period is the same, 2 pi m by 3. 2 pi m by 3. So there is no change in the time period. Okay. Now what about the pitch? So you are asked to calculate the y coordinate of the particle and crosses the y axis for the first time. So initially this is the circle. So ultimately the circle crosses the y axis first time for the advancement. So what is this? This is nothing but the pitch. So what is this pitch? Pitch should be equal to half a t square. Nah, pitch should be equal to half a t square. What is A? A is basically Q into E by M into T square, means 2 pi M by Q whole square. Okay. So ultimately it becomes 2 pi square M E by Q into B square. Okay. So helical path with variable pitch again, because both electric field and magnetic field are there. Now you are asked to calculate the pitch P2 of the particle when it crosses the y-axis the second time. It is the second pitch. The second pitch means first pitch, then it will be starting at the second pitch. So this is the P2. P2. The P2 should be equal to half into A into 2t whole square minus half A into T whole square. Okay, that is half A into 3t square. So half into A means QE by M into 3, 2 pi M by QB whole square, means 6. Option B. Okay, second time. Similarly, third time, fourth time, you can calculate. Every time the pitch is going to increase. Every time the pitch is going to increase. Electron is moving along the positive x direction with the velocity of this. It enters a region in the electric field pointing along the positive y direction. যেটা তার বললাম যে আমার y axis, this is the x axis, and the z axis. Electron is moving along the positive x direction. So electron is moving along this. Electron actually with the v naught. Okay, with the velocity. It enters a region of uniform electric field 300 volt per centimeter pointed along the positive y direction. So E is acting upward. Okay. The magnetic direction of the magnetic field set up in this region such that the electron keeps moving along the positive x direction. So because of this electric field, the electron will feel a force in the upward direction or downward direction. Downward because it will equal negative. So there is a force on the electron, E into capital E. So if I allow this force to be there, so particle will move in the downward, bend in downward direction. But you are asked to make the particle to move along this positive direction, the same direction. That means there must be some another force upward acting. Okay. Now that upward force that must be acting upward should be the magnetic force. So magnetic force should be upward Fm. Okay. Now how to take put that magnetic force upward? So place your palm upward. Stretch the finger V0. Place your palm upward. Stretch the thumb toward the V0. So then finger is crossed. There is a force on the positive charge part. But that means the magnetic field should be reversed. So toward the dot direction, that is Z direction. So if I put magnetic field in this direction, B, so can I ensure that there is now magnetic field give a force on this electron in the upward direction? So now the particle is balanced, force is balanced. So option is towards the positive Z. That means either option C or option A. Now you have to calculate the magnitude of this. So for that, you should equate these two forces. ইলেকট্রিক ফিল্ড ডাউনলোড তো বলাই নি, আমি তো আপওয়ার্ড দেখিয়েছি, পজিটিভ ওয়াই বলা আছে, দেখো ইলেকট্রিক ফিল্ড তো পজিটিভ ওয়াই বলা আছে, আমি তো বলছি না এটা। ইলেকট্রিক ফিল্ডটা উপরের দিকে, তার উপর ইলেকট্রনের ফোর্স নিচের দিকে আসবে না, ইলেকট্রন তো নেগেটিভ চার্জ, ইলেকট্রন বলা হয়, ফোর্স নিচের দিকে রেখেছি, এটা ফোর্স, এটা ফিল্ড নয়, হয়েছে? তাহলে কন্ডিশন ইজ দ্যাট not to make the electron keeps moving along the x-axis, the force was balanced. So Fm should be equals to Q into E, and E into W. Okay, so it is BeV should be equals to E into E. E cancels out for a value. So ultimately B should be how much? B should be equals to E by G. Okay, electric field is given as 300 volt per centimeter. Means centimeter means 100 meter, and velocity is how much? 6 into 10 to the power 6. 6 into 10 to the power 6. কত হবে? দুটো দুটো চারটে, উপরে চলে গেল, দুটো হয়ে গেল, তাহলে 0.5 into 10 to the power -2, না মানে 0.5 into 10 to the power -2, মানে 5 into 10 to the power -3, তাহলে কোনটা হবে? সিটা হবে। কারণ আগেই চেক করে নিচ্ছি, ইট ইজ অ্যালং দ্য পজিটিভ জেড ডিরেকশন, ম্যাগনেটিক ইজ 5 into 10 to the power -3 টেসলা, হয়েছে?